So you can tell this is a multiple regression because there's an x1 and there's an x2. So this is a multiple linear regression, and our idea is we have a variable x1, this is problem number 10, and we have a variable x2, and we want to use both of them to predict y. So we're going to have an equation y equals some number, which is like the intercept, plus the first slope, slope number 1 of x1, plus another number, which is slope number 2 for x2. So in simple linear regression, it ended after one variable. So this is simple. But in multiple, it goes on. Okay, so find the least squares regression line. Let's do this in StatCrunch. Works exactly the same way in Excel as the other parts do. In Excel, if we did data analysis, regression, in the input X range, instead of highlighting one column, we highlight all the X's. And that's how to do a multiple regression in Excel. So it's the same as linear simple regression. You just put in all the X data in the X range. For StatCrunch, it's also pretty much that way. Well, we need to open the data in StatCrunch. You can see there's an x1 and an x2. So stat, regression, multiple linear. So now we have more than one x. So y is the y, and x we have to select both of them. Incidentally, if you wanted to use this program for simple linear, it works. Just select one x. But it's designed to select multiple x's, compute, and here we have a much larger output. Okay, so we have the intercept, and we have the slope for x1, and we have the slope for x2. We have a whole bunch of p-values and statistics. These statistics are testing each individual variable. This is testing the x1 variable by itself. This is testing the x2 variable by itself. What StatCrunch calls the model is testing the two variables together, and that has an F distribution. Okay, so lots of things going on, but let's do part of it at a time. The intercept is the one without the any x's, 3 decimal places, minus 12.509. Okay, the first slope, 1.334. Okay, I'll show you that again. And x2 is minus 414. Okay, so you're used to running the numbers in StatCrunch. These are the coefficients, the one under the estimate. Okay, so how did I get to this? I'll do it again. Stat, regression, just like before, but we're going to choose multiple linear because this is a multiple linear regression. Sorry, I had to cough. For the y variable, we choose y. Just like in some of the other routines we use in StatCrunch, when you want to select more than one thing, you do either a shift click or a control click. So I'll click on x1. Now I'm holding down the shift key and I'm clicking x2. That will select both of them. then compute and we get the output. Okay. Draw residual plots. Create the residual plot for air temperature. Air temperature is X1. So let's see what we have here. Okay, so we don't have anything here. All we have is the hypothesis test. So let's go back and ask for more. So we're going to scroll down. The first time I'm using these StatCrunch routines, you notice I only do the very top, just kind of the standard things. We want the residual plots, so we'll go down, 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 down. Here, I talked a little bit about stepwise regression. There's the stepwise possibility. Graphs. We want residuals. Let's see. Residuals index. Nope, it's not any one of these. We want residuals versus X. Partial regression. So what I'm going to do is I'm going to save the residuals. So I'm going to compute. And you see now the residuals are saved. They're saved as a column. So the residual plots for X1, graph, scatter plot. The X1 variable is across as the X, and the residual plot has the residuals up and down as the Y. Even before we do this plot, I can tell you that some of these are not possible answers. For example, take B. It might actually be easier to see on this little plot. The residuals or the errors are up and down. In plot B, all the errors are negative. Okay, I'll show you that in a second, Michael. All the errors are negative. That can't be. We're going to be correct on the average. So plot B is not a possibility. Plot C is not a possibility. We cannot be always overestimating or always underestimating. That's not the best estimate. So it's either A or D. So if we compute this plot, we see that X1 goes from minus 15 to plus 15, and that's A. Okay, so the question was, how do we get the residuals? When I did the stat, regression, multiple linear, we chose the Y, we chose the X's with a shift click. Then when I went all the way to the bottom, it says save. And you can save all kinds of different things. I just clicked on residuals and it saved the residuals. And when I clicked on, I'm going to cancel that right now because we've already done this. I had clicked on residuals, and when I hit compute, StatCrunch gave me a new column that were the residuals. These are the errors. In other words, the first prediction is 1.23 too low. The actual is 1.23 higher. The second prediction is 1.8 too low. The third prediction is 1.1 too high. These are all the errors of our predictions. Okay, create a residual plot for wind speed. That's the other. So we want to do the same thing, but for X2. Choice A is not possible because the residuals or the errors are up and down. The errors cannot all be negative. Let me draw you a picture of what happens. So let's say these are all points. So this is simple linear regression. So these are a bunch of points. And let's say we draw a line like this. That means all the errors, everything is above the line, so the error is positive. This one is positive. This one is positive. If all the errors are positive, that means the line is underneath all of the points, and that can't possibly happen, right? The best line through the points can't possibly be underneath all of them. So choice D were all positive residuals. That's not possible. That means the line is underneath everything. Choice A, the residuals are all negative. That's not possible. All negative residuals would correspond to a line that's too high. These are all negative residuals. So it's got to be B or C. Let's see which one it is. Graph, scatter plot. We want the x2 now going left and right as our x variables. Still the residuals for the residual plot. Compute. And if we compare this residual plot to B and C, it's clearly B. Okay? It's not A or D because it can't be always positive or always negative. It's pretty clearly not a straight line. It looks like a U. Now the question is this a good model or not? So let me talk a little bit about a good model. A good model means that it explains all the patterns. Okay. A good model, one of the criteria is that it should explain all the patterns. Here we have a residual plot that looks like a U. We did a little bit of this last week. Since the residual plot looks like a U, that means there is a pattern there that's not explained. Right? Here's an unexplained pattern. So like last week I was saying that in my terminology, I would call this an incomplete model. It's not a bad model. It's a great start to a model, but it's incomplete. There's still more in there to be gotten. So it does show a pattern, so the linear model is not appropriate, or at least this particular linear model is not appropriate. We're missing something. Maybe there's another variable. There's something else. We have to make our model at least one step more complex.